Hi, let's do some more calculus. Woo woo! What do you think we're going to talk about today? Did you say the derivative? Yeah! I'm hoping you said derivative, but maybe you said slope of the tangent, which that's the same thing. And now we're going to add one more thing to that, which I think we've been saying a little bit already, but I'm going to really emphasize it today, is the derivative is the instantaneous rate of change. The slope of the tangent, I can speak, slope of the tangent, the slope at a point. So in here, this is on Daily Lessons 106, only one page today, don't be so sad. But on this, when the value of the derivative of a function is positive, we say the function is increasing. Great, so we did this a little bit before where we said f prime is positive, that means the slope of f is positive, the function is increasing. So we did this a little bit, we'll do it more, we'll come back to this. But when the value of the derivative of a function is negative, we say the function is decreasing. So again, f prime is negative, f of x is decreasing. That means the slope of f is negative. So all those things we can still say. But what I'm going to talk about and what we're going to use in the future is what does this mean in context? So if you have a problem, like some actual problem involving like words or whatever, what does that mean? So in here it says when speaking of quantities of increasing or decreasing, they do so at a certain rate. So this actually has lots of and I am not even saying real world in the quotes right now because it actually has real world implications. If we're talking about the rate that something is happening and not just driving, but we could be talking about the rate. So if we're talking about airflow within a hospital, so if someone is on oxygen, just because that's the one that I think of right away, if someone has to have oxygen, what is the rate that oxygen is going into their body? And so we can talk about it that way. There's lots of other instances where this would happen. We're going to start out with some real world ones so that you can get an idea and kind of be comfortable with this. But if we talk about this as the derivative is the slope of the tangent, we still want to talk about that. We can also say this is the instantaneous rate of change or the rate that the function is changing. So in here it says the number of people entering concert can be multiplied by this function. So this is the original and it's talking about this is the number of people. So if I want to find out, and it says T represents the number of hours after the gates are open. So gates open for a concert, this is the number of people that have entered after T hours. If I want to find f of 1/2, that's half of an hour, or after 30 minutes. If I find f of 1/2, this is just the function value at a half. And we talk about this as the number of people. So whatever I would get here would just be, this answer would be so many people. So let's actually do this though, because this problem is asking me to find f of 1/2 and then f prime of 1/2 using correct units. So I did this already for 1/2. And explain which the values this represent. So we're going to do that in a second. But I'm going to say right now, f of 1/2 would be after a half an hour. How many people are there? So this is where you're going to want to go into your calculator and go to y equals. So I turn it on, go to y equals. And if you have a Casio, skip ahead, do it your way. 560, and then I'm going to do e. So second, go down, push e. You can push this up here. E in this is raised to a power sine of x. So it says t here, that's okay, I'm just going to put x. If your calculator is in the wrong mode, so let's say you have it in degrees, this is going to mess up your answers. So particularly if you're in physics, you go back and forth a lot between degrees and radians. If you're just taking calculus, change it now so it's in radians. Okay, so I'm going to second quit, go back to y equals, that's still here, which is nice. And then you can do this a couple ways. You could either just go to the original graph. I'm going to say, I'm going to just graph this and see what it looks like. And I didn't check my window at all, but maybe I want to see, I want definitely what is the time after half an hour, and I can see nothing is really appearing on my graph. So why don't I change this to, let's say, I don't know, I can do up to 10 hours. And there's going to be a lot of people at a concert. I don't know how many. Let's do 10,000. I don't know how many. It's got to be that many. If it's, oh, it's not that popular of concert. It looks like it's way down here. So why don't we do instead? It's funny. Time when people go to concerts. Okay, maybe not funny. Too soon? I don't know. So here's 5,000. Whatever. It doesn't actually matter. Just make sure that your graph is on the page in some way. And so what I'm going to do next is I'm going to put second, and then calc. So let's trace. I'm going to go down to the value, which is just number 1. If I push enter, I can type in 1/2, and then I push enter again. And what this is going to do is my function value is going to be this. And so I'm actually going to put 904 point, and even though this looks crazy, I'm going to write 481. And this is an example of where I truncate instead of round, but you can do either one. Both are acceptable. So this says 4819. You could have said 482 and rounded it appropriately, or you can just truncate, which means cut off after that third decimal place. Oh, maybe right there. The only time I want to give a whole answer, even if we're talking about number of people, which obviously there can't be 0.481 of a person, the only time you want to round to the nearest whole number is if it says round to the nearest whole number. So right now I'm just going to keep it exactly like that. And then in the explanation, maybe I'll say 904, or I can just keep it the same. So this many people. If I wanted f prime of 1/2, I can use the same graph because I already did all this work, or you go back to the home screen. There's a different way that you could do this with Math 8. Go second, and then I'm going to push calc, and I'm going to go down to dy dx. So this is number 6. You could push 6, or you could just go down to number 6. And it's going to say it doesn't look like it did anything, but what I'm going to do is just type in 1/2 again, and it comes up with the x. And you can see right now, this time, it will say dy dx is, this says 793.757. And again, I'm going 3 places after the decimal. Really important that you do that, 3 places after the decimal, because if you only go 2 and it's on the AP exam, they just won't accept that answer. They'll be like, nope, don't see anything there. I can't read that part. So in this one, I've got derivative, and I have to think about what this means. So if we're talking about the derivative is a slope, and we've got this function where this function was just, this is the number of people. Think about it, it would be the number of people on this axis, on the y-axis. On this side, it would be time, so hours. If I was thinking rise over run, or my rate of change, it would be people per, on this side, hour. So people per hour. Okay, so I found the values of f of 1/2, f prime of 1/2, using correct units. So I have the correct units here, but I need to explain what each of this means. So I'm going to say, I can say at 30 minutes or at 1/2 hour, because this is at a particular moment, after the gates have opened. And I'm going to use exactly their language. Sometimes this sounds a little funky though, just like in English if we're talking about it, but I'm going to use exactly what they have. So at 1/2 hour, so like at a moment after the gates have opened, this was saying this is the number of people entering a concert. Okay, so number of people entering is weird because it's like, how many people is that at the gate, inside? I don't know. We're not going to debate that. We're just going to use the language that they are using. So I'm going to say 904, and if you want to put 0.481, just because maybe that's, if we're talking about are entering a concert, maybe that's talking about like somebody's like partway through. So I'm going to keep this for right now. People are entering a concert. If you said have entered a concert, that's okay. Are entering, because this kind of sounds like a rate, but I'm using exactly what they're using. Okay, then the next one, this is an instantaneous rate of change, so I'm going to say at a 1/2 hour after opening. Really important, you have to, or the gates have opened. Gates, gate. I don't know, maybe they have multiple gates. Yeah, they have multiple gates. And then I'm going to say people are entering at a rate of, because now we're talking about the rate of change. So people are entering, so same language they used before, at a rate of 793.757. And this one is really important that you keep the decimal, because that could like that could change your answer really quickly. And it's just a rate, so it's okay if it's part of a person per hour, people per hour. Okay, how many people have entered the concert 2 hours after the gates are open? So this is asking, what do you use? Do you use F or F prime? The clue is here, how many people? It's not people per hour, so this is just people here. So how many people have entered the concert 2 hours after the gates have opened? I'm going to go to my graph, second, calculate, and just do the value at 2. And I get F of, and it says how many people have entered, so I can also be like this many people have entered, but if I do F of 2, I get 1390.2435. So again, you could go up and you could say 0.244. So 1390.243, and this is people. And then when I'm explaining this, then I can go down to just 1390 because that's how many people have entered. Like, you're not going to do part of a person. So I'm going to say 2 hours after the gates are opened instead of have opened because I'm using what they're using. 1390 people have entered. 1,390 people have entered. Okay, and then I'm going to also find, in this, it says, is the number of people increasing or decreasing? Anytime I want to know increasing or decreasing, I don't just want to look at the function, although I can kind of get some idea right now that you can see the function is going down, it's decreasing. But what I really want to look at is the derivative. So f prime of 2, because this is how I'm going to justify your answer. This says justify over here. This is how I'm going to do it. So I'm going to say f prime of x, which is dy dx, and I'm going to say at 2, and I can see the derivative is negative 578.545. And again, this was people per hour. I found this from here. Not sure if you could see it. There you go. And then I'm going to say, is the number increasing or decreasing? At 2 hours, so I'm saying in a specific time, the number of people entering is decreasing. Notice I'm not saying people are leaving. I'm saying the number of people entering is decreasing. I always want to go with the language that they have. It's either increasing or decreasing. So the number of people entering is decreasing. And how do I know this? Justify my answer. And I'm going to say as f prime of 2, which I already showed over there, is negative. Ta-da! Did it. Okay, one more question. I know this is taking a while, but a lot of it's calculators making sure that you're comfortable with this. After being poured into a cup, coffee cools so that its temperature is represented by this function. So we've got coffee pouring into a cup. T is measured in minutes, and T of T is measured in degrees. So if I've got this graph, I've got something over here, degrees, something over here, measured in minutes. Just so we can get an idea. So if we're talking about this original function, we'd be just saying degrees. If we found a slope of this line, whatever it would be degrees per minute, because it's always rise over run. Okay, what is the temperature of the coffee 5 minutes after it has been poured in the cup? This was in minutes, so I can just say, well, what's T of 5? And this one, I'm going to show you a little bit different. If you want to do this on the home screen instead, if your calculator hasn't been updated, you want to do it the same way that you did before. But if I go and I just go to the original home screen and I say this is 70 plus 110 e to the negative t over 2. It's really hard to see, but that's a t, so I'm going to say negative x over 2. And then you're like, yeah, that answer doesn't mean anything. What I want to do is I want to say 5, and then I'm using this button down here, store for x. And then I'm going to go up here again, because that means anywhere I get an x, I'm going to put in 5 instead. And I get this answer of 79.029. And it doesn't say anything else, but I have to be really careful because it's talking about temperature. I don't know. I don't want this to be in Kelvin or anything. So I'm going to say degrees Fahrenheit. Then the next one Is the temperature decreasing faster after 1 minute or 3 minutes? Okay, this one's going to be difficult. Well, not really. It's just there's a common mistake on this one. So if you haven't been paying attention to anything else, now's a good time to pay attention, not to not pay attention. That would be terrible. Is the temperature decreasing faster after 1 minute or 3 minutes? If we're talking about the rate that something is increasing or decreasing, what you have to do is you have to look at the derivative. So I want to look at what is t prime of 1, because that's 1 minute after, and what is t prime of 3. So if I want to, I can say I'm on the home screen, which I think actually the graph may have been easier here, but I'm showing you this way. If I say math 8, that's the one that gives you the dy dx. I would have to put in this whole function again, 70 plus 110. And then we would have e to the negative x over 2. So I put in this whole thing, and then you have to say at x is equal to 1. And I get an answer of negative 33.359. And if I'm thinking about a rate, remember this is a slope of degrees. This was a graph of degrees. This was t of t up here. So this would be degrees per minute will be the rate. Degrees Fahrenheit per minute. In the next one, I'm going to do the same thing, but instead of typing all this again, I'm going to go up here, copy it, and then I would set it at t equals 3. And I get negative 12.272. So if you didn't think about this right away, this is the same case with anything that is cooling. If we're talking about something cooling, it's not just going to cool like forever. So if we get something hot out of the oven, or if we get coffee out of, like put it out of the container that it's in and into the mug, when you pour it, it's going to get cooler. And it's going to keep getting cooler and cooler and cooler, but not forever. It's not like it's going to, if you sit it on the counter, it's going to turn into ice. What's going to happen is that it's going to cool really fast. And then as it gets closer and closer and closer to room temperature, it's going to even out a little bit. So it's going to, because that would be weird if it kept cooling forever. That would be kind of a crazy, like, superhero type business. And yeah, whatever. So if we're talking about a rate, this, I can see at 1 minute, it is cooling faster. But what you can't do is, I can't just say at 1 minute, or I'm sorry, I can say at 1 minute after the coffee is poured. I'm going to do the first part correctly, and then the second part I'm going to need to add something. Coffee is cooling faster. Or I should say coffee's, I'm going to use the same thing. The coffee's temperature, I don't even want to change it to cooling, is decreasing faster than at 3 minutes. Okay, so I did that. I answered the one question, is the temperature decreasing faster 1 minute or 3 minutes? So I answered that. Give a reason for my answer. Okay, this is what some people are going to say. I've got t prime of 1, I've got t prime of 3. And what a lot of people say is, well, look at this one. This is a much bigger number, 33 and 12. That's how I compare them. This is a bigger rate. It's steeper. So what they do is this. Don't do that. Don't volunteer as tribute. Because if I look at this, is this a true statement? Not so much. Not a true statement. What is a true statement is this. Now I can say, oh, the absolute value of t prime of 1 is greater than t prime of 3. So then if we're talking about a rate, this now makes sense. So save yourself a whole lot of writing and explaining and write this instead. If you write a math statement that doesn't make sense, like just something that is just wrong, you couldn't get the point for the justification, even if you knew what you were doing. So I want to make sure that you're including absolute values, that you're your friend in this case. Thanks so much for being awesome. I hope you are well wherever you are. And please ask me, please reach out if you have any questions. I appreciate you, and I just thank you for learning. Okay, thanks, bye.